Good morning, students. The relative concept is a very simple and meaningful concept. Consider two objects. Consider an object A and object B. Let their initial position at t equal to 0. It is written as x of A 0 and it is written as x of B 0. Let velocity of object A is written as VA and velocity VB. It is written as V of B. Then what is relative velocity? Relative velocity is defined as velocity of B with respect to A is equal to velocity of B minus velocity of A, or velocity of object A with respect to B is equivalent to velocity of A minus velocity of B. This is called relative velocity of B with respect to A, velocity of A with respect to B. These are the two equations. Now at later time, if A is an object, B is an object, this is at time t equal to 0, the object was located. It is called position of A, position of B. Let VA be the velocity and VB the velocity. At later time, I can say the position of A is detected as it is a function of time. Similarly, object B is a function of time. Now, how this position depends upon time means position of A, which is depending on time at some other time interval, how this later time position is related to initial position, how the object position, later position depends on the initial position. With the help of these velocities are mathematically written. Let position of A at a later time is equal to position of A at initial time plus velocity of A into time. This is called equation 1. Similarly, I can write it. This is called equation 1. Similarly, position of B at a later time is equal to position of B at initial time plus velocity of B into t. So this completes my mathematical equation. Yes. Now, I want to write an expression for displacement. Now, the displacement of object A with respect to B is, I'll be writing a very simple mathematical equation. Object A is x BA. XBA stands for displacement of object A with respect to B as a function of time is equal to XB time minus XA time. This is displacement. This is position of a B at a later time, position of A at a later time. We know this is equation 2, this is equation 1. Let me rewrite it. When you cross check, this becomes plus, this becomes minus. Now I can have position of B at 0 minus position of A at a 0 time. So this gets the first part because equation 2 minus equation 1. Now plus velocity of B minus velocity of A time. This is a simplification. Means when you make displacement of object A to B, displacement of A to the B is written as function of time, position of B at a later time minus position of A. So when I write it, it is equation 2, it is equation 1. 2 minus 1 gives you this mathematical expression. It is x of B 0 minus x of A 0 plus V of B minus V of AT. Now finally the next step, when you look at this relation, this XBA can be written as XBA, displacement of A object is equal to, this whole written equation can be written as XBA 0 displacement, it is displacement with respect to initial position, plus you have this whole equation VB minus VA is written as relative velocity object B with respect to t. So what I mean to write, my mathematical equation is reduced to a simple and meaningful equation. This is, yes, call it as equation 3. So what is this? Displacement of object A with respect to B, displacement of object A with respect to B equal to displacement of object A with respect to B at a 0 time is 0. Hence, velocity BA stands for relative velocity, or I can say velocity of object B with respect to A. I have written here VBA. Velocity of object B with respect to A, velocity of object A with respect to B. So hence I got this mathematical relation. Similarly, I can write, now I can have these two relations. When you cross check these two, VBA is equal to minus VAB. So this is one interesting aspect. Call it as equation 4. And I have written it. Similarly, VBA equal to VB minus VA and VAB equal to VA minus VB. Now, in order to understand what is relative velocity further graphically, look at the first graph. It is position versus time graph. And the slope of this graph gives you, this curve is object motion for object A. This will give you a velocity, that is a slope. Slope is VA. For this dotted line object B, the again slope is VB. Since looking at the slopes are equal, I can say velocity of object A equal to velocity of object B. Hence, the relative velocity between A and B is 0, means both the objects are moving at the same velocity, and this indicates whether you take the velocity here or anywhere, irrespective of the time, yes, both are parallel. Of course, this velocity is constant because slope is constant. The slope for this curve are one and the same. And relative velocity is 0. Yes. Looking at the second graph, think initial, what is this x of A? You can take 10 meter, you can take it as 40 meter. And the distance, this is origin, 0, 10 meter, 20 meter, like 40 meter. This distance is maintained constant, that is 40 minus 10 is 30. Always at any time interval, later time, the distance between two objects remains constant, that is 30 meter. Now look at this diagram. If I take xa equal to 10 meter, xb equal to 40 meter, this is 40 meter, this is 10 meter. Since velocity, this curve has a slope for this, call it as SA, slope for SA is greater than SP. Means this is A curve, object A, this is B. And the slope for this is greater, means velocity of object A is greater than velocity of object B. Numerically, I have taken velocity of A is greater than velocity of B. Velocity of B is 10. Means initially the object is located at 10 meter, object B is located at 40 meter. At later interval at time t equal to 3 seconds, object A will overcross, they will meet, and object A will overcross object B. That's why this is a steep. This slope is a steep, this is less steep. In the sense, slope for A is greater, slope for B is small. Slope greater means velocity is more in comparison to velocity of object B. A velocity more, B velocity less. Initially it was at 10 meter, it was at 40 meter. At time t equal to 3 seconds, both will reach, and the point where it is going to be 70 meter. But after 3 seconds, object A will overtake. This is a concept of relative velocity between two objects, where I can say here VA is greater than VB, here VA equal to VB. Of course, we'll learn one more. For the third case, where one object is moving in a positive direction, call it as positive x-axis. The other object is moving in a negative x-axis. Let the velocity of the object B is minus 10 meter per second and velocity of object A is 20 meter per second. Initially, they are located at, of course, you can say it as 10 meter and you locate it as 40 meter. And initially it is at 10 meter, initially 40 meter, the speed is very high, the speed is small. But at what time they both will meet? At t equal to 1 second, this is 0 second, 1 second, 2 second. This is time axis, negative time axis, positive time axis. This is 3 second, 4 second, 5, as I say, time second. At t equal to 1 second, both will meet. And after 1 second, this A will be going with a positive direction, continuously positive. It just crosses and it goes in opposite. Means A and B are moving in opposite direction, moving in opposite direction. Yes, both are moving in the same direction at constant distance. Both are moving in the same direction, positive x direction. One is moving at 20 meters per second, the other is moving at 10 meters per second. Both are moving at different velocities, both are moving in opposite direction. One is plus x-axis, the other is minus x-axis. One with a velocity 20 meters per second, other with a velocity 10 meters per second. This is called relative velocity 0, relative velocity of, if I take relative velocity of A with respect to B, it is positive. If I take B with respect to A, it is negative. Like this mathematics. VAB is equal to minus VBA. So in this case, relative velocity not 0. In this case also relative velocity not 0. In the first case, the relative velocity is 0.